Hi there, welcome to Numerical Methods and Computations. Today, under System of Linear Equations, I'm going to teach you Gaussian elimination with complete pivoting. Let's start. If you are to solve a system like this, you can write this in augmented form. And by writing this in augmented form, I mean writing the coefficient of the s values and the numbers right after the equal sign. For instance, in equation 1, the coefficient of S1 is 1, the coefficient of S2 is negative 2, the coefficient of S3 is negative 3, and the number right after the equal sign is 0. So you do the same thing to equation 2 and equation 3, and this will give you this matrix in augmented form over here. Next, we identify our leading diagonal, and this is our leading diagonal, and each element in the leading diagonal is called the pivot element. We are going to use the pivot element to reduce the numbers under it to 0. Now, because we are solving this system using Gaussian elimination with complete pivoting, we have to look at this side and pick the highest number in magnitude to become our first pivot element. 5 is the highest number in magnitude over here, so we have to find a way to make 5 become our first pivot element. We can swap column 1 and column 2, and then we swap row 1 and row 2. We can also choose to swap row 1 and row 2 first and then swap column 1 and column 2. I'm going to swap column 1 and column 2. And after swapping column 1 and column 2, this is the matrix we are going to get. Then we swap row 1 and row 2. And after swapping row 1 and row 2, this is the matrix we are going to get. 5 has become our first pivot element, so we can use 5 to reduce negative 2 and 3 to 0. Let's reduce negative 2 to 0. To reduce negative 2 to 0, we have to find a number that when we multiply by the pivot element and add it to negative 2, we are going to get 0. To find that number, we divide negative 2 by the pivot element and negate it. And this will give us 2 over 5. And that is the number we are looking for. So 2 over 5 times the pivot element, which is 5, plus negative 2 is 0. Let's write a relation and put in the corresponding values of R1 and R2. So 2 over 5 times the pivot element. The pivot element is in row 1. So 2 over 5 times row 1 plus negative 2. And negative 2 is in row 2. So plus row 2. And we store our new values in row 2. To reduce 3 to 0, we will do the same thing as we did to negative 2. So we have to find a number that when we multiply by the pivot element and add it to 3, we are going to get 0. To find that number, we take 3 divided by the pivot element and negate it. And this is going to give us negative 3 over 5, and that is the number. So negative 3 over 5 times the pivot element. The pivot element is in row 1. So negative 3 over 5 times row 1 plus row 3, and we store our new values in row 3. We can now put in the corresponding values of R1 and R2 into the relation. 5 and negative 2 will give us 0. 3 and 1 will give us 11 over 5. 2 and negative 3 will give us negative 11 over 5. 0 and 0 will give us 0. Let's put in the corresponding values of R1 and R3 into this relation. 5 and 3 will give us 0. 3 and 2 will give us 1 over 5. 2 and negative 1 will give us negative 11 over 5. 0 and negative 1 will give us negative 1. The matrix after reducing the first column to 0 is this matrix over here. Now that we have been able to use 5 to reduce the numbers under it to 0, we can go ahead and choose our next pivot element so that we can reduce 1 over 5 to 0. Because our first pivot element was in this position, we look at this side and chose the highest number in magnitude to become our first pivot element. Our second pivot element is in this position. So we have to look at this side and choose the highest number in magnitude to become our second pivot element. 11 over 5 is the highest number in magnitude over here. So we are going to maintain this matrix. We are not going to do any swapping. But assuming, let's say, this side was negative 6, then negative 6 would have been our highest value in magnitude over here. We would have found a way to make negative 6 become our pivot element by swapping column 2 and column 3. But that is not the case. Now, to reduce 1 over 5 to 0, we have to find a number that when we multiply by the pivot element and add it to 1 over 5, we are going to get 0. To get that number, we take 1 over 5 divided by the pivot element and negate it. And this is going to give us negative 1 over 11. And that is the number we are looking for. So negative 1 over 11 times the pivot element. The pivot element is in row 2. So times row 2 plus 1 over 5. 1 over 5 is in row 3. So plus row 3. And we store our new values in row 3. We can put in the corresponding values of R2 and R3 into the relation. 11 over 5 and 1 over 5 will give us 0. Negative 11 over 5 and negative 11 over 5 will give us negative 2. 0 and negative 1 will give us negative 1. So the matrix after reducing the second column to 0 is this matrix over here. We can now write our system in the form of an upper triangular system. This is our matrix in the form of an upper triangular system. Let's do back substitution, that is starting from equation 3. We can divide both sides by negative 2 to get S3. And by dividing both sides by negative 3, S3 will give us 1 over 2. And then we put S3 is equal to 1 over 2 into equation 2 to find S2. So wherever we see S3 in equation 2, we are going to put 1 over 2 there. And this will give us 1 over 2. We then put S2 is equal to 1 over 2 and S3 is equal to 1 over 2 into equation 1 to find S1. From equation 1, wherever we see S2, we are going to put 1 over 2 there. And wherever we see S3, we are going to put 1 over 2 there. And this is going to give us S1 is equal to negative 1 over 2. This should be our final answer. That is, S1 is equal to 1 over 2, S2 is equal to negative 1 over 2, and S3 is equal to 1 over 2. But because we swap column 1 and column 2, we are getting S1 is equal to negative 1 over 2, S2 is equal to 1 over 2, and S3 is equal to 1 over 2. We can see clearly that the values for S1 and S2 have interchanged. This is happening because column 1 are for S1 values, column 2 are for S2 values, and column 3 are for S3 values. Take note, if you swap rows, it is not going to affect your final answer. But if you do column swapping, it is going to affect it. You have been able to identify that S1 value has become S2 and S2 value has become S1. We can say from here that our final answer is 1 over 2, negative 1 over 2, 1 over 2 transpose. But in some questions, you can do more than one column swapping, and we can even lose track of our final answer by not being able to identify what value is for S1, S2, S3, and so on. I'm going to show you a way to reverse whatever answer you get when you do column swapping to get the correct answer. We are going to use permutation matrix to do that. And permutation matrix is given as Q is equal to Q1 times Q2 times Q3 up to Qn. And identity matrix is the matrix that has all its leading diagonal values equal to 1 and all other values are equal to 0. This is an identity matrix. In solving our question, we swap column 1 and column 2. So let's swap column 1 and column 2 from the identity matrix to get Q1. Now let's assume that we swapped column 2 and column 3 when we are solving our question. Then we would have swapped column 2 and column 3 from the identity matrix to get Q2. We would have multiplied Q1 and Q2 to get Q, but that was not the case over here. we only did one column swapping. To reverse and get the correct S values, this is giving us S is equal to Q times Y. S are the correct values. Q is the multiplication of all column swapping we did using the identity matrix. Y are the values we want to reverse. By putting in the values, we are going to get this, and solving this will give us the correct S values. Hence, 1 over 2, negative 1 over 2, 1 over 2 transpose. Please, if you haven't subscribed to my channel, make sure to do so. Like and also share this video. Have a nice day. Take care.